Okay, the last chapter is chapter 6. In chapter 6, we talked about discrete versus continuous. Here's some little notes that I figured out about discrete versus continuous to kind of help you decide, because if you don't categorize it right, then you'll get it all wrong. So just pay attention to these little bullet points. In most cases, if it cannot be a decimal, it's discrete. Or if it's in a table, it's discrete. And if you know every outcome and probability, it's discrete. So in a with discrete, you're going to find variance with a discrete set of numbers. Then continuous, you know it's continuous if it says normal distribution, and if it's measurable. And then with continuous, you're going to do the density graph. So to find the mean of discrete, it's going to be the value times the probability plus the value times the probability, continues until you do all of your values. To find variance, it's going to be value minus the mean squared times the probability. You're going to keep doing that. And then the standard deviation is just the square root of the variance. Here, you can use normal CDF, and when you type it in, you do lower, upper, mean, standard deviation, or you can do it by hand and find your z-score. And I'm not going to go over that again because we did that in the second chapter. With this equation, s equals x plus y, I'm going to show you a quick example of that from the notes. So you're going to use this with mean or with your standard deviation. Okay, so we learned this a couple of days ago. So we use bins to figure out if it's a binomial setting. So the B stands for if it's binary, and binary is if the possible outcomes of each trial can be classified as a success or a failure. So it has to have that. I stands for independent. It must be independent, and that means that results from one trial can't tell us anything about the results from the next trial. Number, that's what the N stands for, and that's just you have to have a fixed number of trials. S stands for success, and then it has to have the same probability of success on each trial. So the first equation is probability of a certain value, k, equals the number of arrangements times pk of 1 minus p, and then to the power of n minus k. So that's a lot of variables, but summed up, the probability of a certain value, which is the k value, p equals the probability of success, n equals the number of trials. And then arrangements you can find using this. So when you're finding it, you don't write a bar there. You're just writing it normally. And then this number is to find the arrangements. So you can find it on your calculator, or you can write it out. I like to just do it on my calculator because it's easier. You can do it two different ways on your calculator. You go to math, which is right under alpha, math, and then it's the fourth one over. So here there's an exclamation point. Or you can do it with, the third one down there, and you can type it out. And I actually have an example of that, so I'll wait to show you how to do that. This equation is the same as this equation. I just wrote it differently. When you're finding this equation on your calculator, you can do binom PDF or binom CDF. And if you want to use PDF, it's finding the exact number of successes. If you want to use the CDF one, that's an interval. So let's move on to some examples. Okay, so here we're going to find the average gain. I didn't write any context, I just kind of wrote this out. So for average, as you can remember, you're going to do this number times that number plus 8 times 4 over 38, and that'll equal negative 0.05. So that's the average gain. The same example is in the notes, 6.1, just in case you want to go back over it. And it is on the second page, and it's this one. It says value probability. So if you want some context or if you want some extra practice, you can go back to that point in the notes. I did another example for mean, variance, and standard deviation, and that is also in the notes. It's on the next page. I went ahead and wrote it out for us. So to find the mean, you do the same thing we did up here. So that'll be 1 times 0.63 plus 2 times 0.295 ... You guys can go ahead and work that out. The example in the packet actually tells you what the mean is, but I decided to show you another example of how to find it. And from this, you're going to get 1.457 for your mean. And you will need that when finding the variance. So when you're finding the variance, you're going to do 1 minus the mean, which is 1.457, this quantity squared times the probability, which is right here, times 0.63. So you're going to do that for every single one. The answer for the variance is 0.6602 if you want to check yourself after trying that one out. Then to find the standard deviation, you're going to square root that number, and your standard deviation will be 0.8125. Okay, now to do an example of the exclamation point thing. So how many groups of, I'll keep this out here so you can see the formula here. So how many groups of 3 people can be created from 15 people? So on top, you're going to have 15, then over, or not over, sorry. That is actually what you don't want to do. 15, and then 3 on the bottom, but no line. So to find it longhand, you're going to do 15 exclamation point over 3 exclamation point times 15 minus 3, and then another exclamation point. So you guys can go ahead and figure that out. I'm going to do it on the calculator. I'm going to show you both ways. So let's get a fraction bar in there. Okay, so on top, 15, and then as I showed you earlier, math, probability 4 over 3, and then that times 15 minus 3, which is 12, and then you're going to do another exclamation point after that, and you get 455. But you can also do it another way, where you can go math, and it's the third way down, and you're going to do 15 and 3, and you get the same number, 455. Then I'm going to show you another example from the notes. So I decided to do an example from the notes. So I'm going to show you how to do it by hand, but then we'll also go over how to do it on the calculator. I usually do it on the calculator, but it's good to know how to do both. So this is find the probability that the player gets doubles twice in 4 attempts. So as you can see, my arrangement, which we're using this equation here, my arrangement is 4, 2, because there's 4 attempts, and it's the probability that he gets doubles twice. So that's why it's 4, 2. And then the P of P to K is 1/6, because that's the probability, and then we did it twice, and that's why we have a 2 there, multiplied by 1 minus P, which is 5/6. So you do 1 minus 1/6, and that's how you get the 5/6, times n minus k, which is 2. So 4 minus 2 equals 2. And then you'll end up getting 0.116, but I'll just show you how to do that on the calculator in case you don't know. So you'll go second, and then vars, which is right there. Also, this one's binom PDF because we're doing an exact number. If we are doing binom CDF, that'll be an interval. But we're doing an exact number, so that's why it's PDF. So that's close to the bottom. It's going to be this one. So trials, there are 4. Probability, 1/6. And then the x value is 2. And you get 0.115 or 0.116. And that is how you find it on your calculator. And that is it for chapter 6.